Alright, in this problem we have determine if xenon tetrafluorine is polar or non-polar. How do you determine if a compound is polar or non-polar? Some people might do the unequal versus equal sharing of electrons. However, how I determine if a compound is polar or non-polar, I follow a set of rules. So what are those rules? Well, the first set of rules, if these are the polarity rules with being non-polar. Now, if the element or compound breaks one of these rules, it is polar. Just one. No ifs, ands, or buts. So, what's rule 1a? This is if the central element has no lone pairs. If the central element has no lone pairs, you look, 1a, central element is connected to the same elements. Rule B, central element is the least electronegative element in there. However, there are you might come across a compound that does have lone pair of electrons, and you need to determine if they're polar or non-polar. There are another set of rules to that, which are simply this. If the central element has lone pairs, you follow the same rules from 1A and 1B. They become 2A and 2B. I just didn't want to write them over again. So you just add two more. You have dipole arrows cancel out and lone pair dipole arrows cancel out. Those are the two new rules for if they have lone pairs. Now going to our original equation, xenon tetrafluorine, when we draw the Lewis structures, we see it has no lone pairs of electrons. So we follow rule 1A and 1B. Is xenon connected to the same element? Yes, so check. So far so good. And is it the least electronegative? Yes, fluorine is one of the most electronegative elements out there, so it is. And how you determine electronegativity? Just remember it increases from the periodic table left to right, bottom to up. So here we go. Is it polar or non-polar? Non-polar. It followed rules 1A and 1B to heart. So this is our answer. However, there might here's an example of a molecule being polar by following my rules. Here's NH3, ammonium. When we draw the Lewis structures, we see it does have a lone pair. So we follow rules 2. Rules 2 states you got 2A and 2B, same from 1, central element is connected to the same element. B, central element is the least electronegativity. C, dipole arrows cancel out. And D, lone pair dipole arrows cancel out. As we look, start off from 2A. Is it connected to the same element? Yes, hydrogens. Moving on, 2B. Is it the least electronegative? No, nitrogen is up there with fluorine and oxygen, so it is higher electronegative than H. So it is polar because it breaks rule 2B. All it needs is to break one rule, therefore it is polar.